Hello, welcome to this lesson on approximation and estimation. So we start with rounding off numbers. In rounding off numbers, we have round up and round down. The digits 0, 1, 2, 3, and 4 are rounded down, while the digits 5, 6, 7, 8, and 9 are rounded up. The rounding up and rounding down will be better explained in our examples. So we start with example 1. For example 1, round off 76,524 to the nearest A, 100, B, 1000. So we start with A. We are going to identify each digit from behind. This is unit, this is tens, this is 100 digits. Since we are to round off to the nearest 100, so we are going to stop at 100 digits since we are to round off to the nearest 100. So we then check the digits after it, that is after 100. The digit is the tens digit, and the tens digit is in the range of the numbers to be rounded down. So to round it down now, it has no effect on the 100 digits. So and thereafter we return the other two digits as zeros, so that we now have 76500. So we have 76500. That's the remaining two digits. So if you read it now, 76,500. 500. After 500, there's no any other number, which means we have rounded off the number to the nearest 100. So we go to be 76,524 to the nearest 1000. Again, we name the digits. This is unit, this is 10, this is 100, this is 1000. So since we are to round off to the nearest 1000, we recognize this 6 as our nearest 1000. So what we then do is we check the digit after it, which is the 100 digit. Since the 100 digit is 5, we are going to make it 1 and add it to 6 to make it 7. That is rounding up. We are going to round up the 5, make it 1, and add it to the 1000 digit. It becomes 77,000. That is, we are going to return the remaining 3 digits as zeros. So we have 000, 77,000 to the nearest 1000. So that's all for problem 1. We go to problem 2. For problem 2, round off the following to the nearest whole number. So we have A 18.45, B 9.78. So starting from A, the whole number part is 18, while the decimal fractional part is 45. So we are interested in only the 18. But before we go, we check the next digit after 18. And since it is 4, we are rounding it down. The 4 will be rounded down, meaning it will not have effect on this 18. So we have 18.45 to the nearest whole number as 18. And that's all for A. Then we go for B. For B, we have 9.78. The whole number part here is 9. Remember, we are checking the next digit, which is 7. Since 7 is in the category of numbers to the rounded up, so we are going to add 1 to this 9. It becomes 10. So that 9.78 is equal to 10 to the nearest whole number. And that's all for 2. We go to problem 3. For problem 3, round off the following to 2 decimal places. We have A 6.743. This is 3 decimal places. We count the decimal places after the decimal point. So after the decimal point, we count the digits 1, 2, 3. That's 3 decimal places. Here also is 3 decimal places. So we are to reduce it to 2 decimal places. Starting from A, for the 2 decimal places, we'll be interested in 6.74. 6.74. Then we now check the next digit. Since the next digit is not up to 5 and above, we are rounding it down. So it will not have effect on 4. So that our answer to 2 decimal places will be 6.74. So we go for B. For B, we have 24.869. And for your information, we are interested in 2 digits after the decimal point. So we still maintain the ones before the decimal point. We're interested in 24.86. Then we check the next digit, which is 9. Since it is going to be rounded up, we add 1 to this 6 to make it 7, so that our answer now will be 24.87 to 2 decimal places. And that's all for problem 3. We then go to problem 4. For problem 4, round off the following to the nearest tenth. Nearest tenth means 1 decimal place. You still remember from our place value, tenth, when they say tenth, it is the digit after the decimal point. The digit after the decimal point, which is 1 decimal place. So nearest hundredth will be 2 decimal places. Nearest thousandth will be 3 decimal places. Please take note of that. So we go to A. To the nearest 10, we are interested in 0.5, but we check the next digit. Since it is 8, so we are rounding the 8 up by adding 1 to the 5, so that we now have it as 0.6, which is 1 decimal place or nearest tenth of 0.586. Then we go to B, 212.235. To the nearest tenth, I told you it's to 1 decimal place. So we're interested in 312.2. Then we check the next digit, which is 3. That one is going to be rounded down. So it will not have effect on our final answer, which is 312.2 to the nearest tenth. So that's all for problem 4. Then we now look at significant figures. It's still part of rounding off numbers. 1, 2, 3, 4, 5, 6, 7, 8, and 9 are significant figures. 0 is not a significant figure except it is between numbers. So we look at 376 is 3 significant figures. So we also have 0.076 and 7,600 are both 2 significant figures. These preceding zeros are not significant figures. 7,6 are the significant figures. Also, 7,6 are the only 2 significant figures. The 2 zeros after are not significant figures. So we look at 1004 as 4 significant figures. How? Because these 2 zeros are between 2 significant figures, 1 and 4. Therefore, the 2 zeros will count as significant figures, which makes 1004 as 4 significant figures. So we look at some problems rounding off numbers to certain significant figures. As in problem 1, approximate the following to 3 significant figures, 2 2 significant figures. We are starting with A. So for A, we have the first one to 3 significant figures. The number itself is 1, 2, 3, 4, 5 significant figures because this 0 is between 4 and 7. Therefore, it is a significant figure. We're interested in the first 3 significant figures. So we are interested in 4, 0, and 7. Then we check the next digit, which is 5. We are rounding it up, meaning we are adding 1 to 7, so that we now have 408. The remaining 2 digits now will be returned as zeros. So we have 40,800 as 3 significant figures. So we go to the second part of A, which is 2 significant figures. We're interested in 4 and 0. Then we check the next number. The next number also is to be rounded up. Therefore, we are going to add 1 to this 0, so that we now have it as 41. The remaining 3 digits now will be returned as 0. So we now have 0, 0, 0, which gives the final answer 41,000 to 2 significant figures. So we go to B. For B, the first part is 3 significant figures. We're interested in 7, 4, and 9. And the next digit is not up to 5, so we are rounding it down, which means it has no effect on 7.49. So we now have it as 7.49. Ideally, this 3 is to be returned as 0, but because we are dealing with decimal point, the number is coming after the decimal point, the 0 is negligible. So we now have our final answer as 7.49 to 3 significant figures. Then the second part, which is 2 significant figures, we're interested in 7 and 4. We check the next digit, which is 9. So it has to be rounded up, which means we are going to add 1 to this 4 to make it 5, so that we have 7.500, the remaining 2 digits. And we said it can be ignored. So we have our final answer as 7.5 to 2 significant figures. So we go to C part of the problem. For C, we have 0.08649, and the first part is 3 significant figures. These zeros are not significant figures. So our significant figures start from 8, 6, and ends at 4 for 3 significant figures. So we have 8, 6, 4. We check the next digit. Since it is 9, we are rounding it up. We add 1 to this 4, so that our final answer will be 0.0865. Then 0. We said it's not necessary to add this 0. So we have our answer as 0.0865 to 3 significant figures. So the second part, which is 2 significant figures, we'll be interested in 8 and 6. Since the next digit is now up to 5, so it is going to be rounded down. Our answer will be 0.086, adding the 2 zeros, which we said it is negligible, it's not necessary. Therefore, our final answer is 0.086 to 2 significant figures. And that's all for C. We go to D. For D, we have 0.00004954. This is 4 significant figures. We are going to reduce it to 3 significant figures and 2 significant figures. Starting from 1, which is 3 significant figures, we are interested in 4, 9, and 5. So since the next digit is less than 5, we are rounding it down. So we are going to have it as 0.00495. We told you that 0 is not important, so we're not bringing in 0 again. So we have it as three significant figures. Then for the second part of 1D, two significant figures. We'll be interested in 4 and 9. The next digit is up to 5. So we are adding 1 to this. So it becomes 0.0050. So at that point, the 0 after the 5 is going to be taken as two significant figures. So it will be taken here now as two significant figures. So this 0 after 5 is going to count as a significant figure. We cannot take the 0 before it. So that is it, the solution of problem 1D and the entire problem 1. And this is the highest we can take under significant figures. So we go for estimation. The use of approximated values in calculation is called estimation. This approximation, we already know it is rounding off numbers to either decimal places, significant figures, or the nearest whole number, nearest 10 or nearest 1000. That's what we'll be doing in the next slide. So we have our problem 1. By rounding off each value to the nearest whole number, estimate the following. A 9.8 plus 8.323, B 18.3 minus 7.98, and C 2.9 times 39.57. So we start from A. So 9.8, this is the whole number part, and we are rounding it up to the nearest whole number. So the number after the decimal point is to be rounded up. So we add 1 to this 9 to give us 10. Then for the second part, this is 8.23, and the 8 here is the whole number part. The next digit is 2, which is going to be rounded down because it's not up to 5. Therefore, we have this second number as 8. So we have it as plus 8, which gives 18. That's all. So that is all. Then we go for B part of the problem. For B, I have 18.3 minus 7.98. 18 is the whole number part here. So we check the next digit, which is 3. It is not up to 5. So we are rounding it down. So rounding it down, we have 18.3 as 18 to the nearest whole number. Then the second number is 7.98. So the whole number part is 7, and the next digit here is 9, which has to be rounded up since it is between 5 and 9. So we add 1 to this 7 to become 8. So that we have 18 minus 8. And 18 minus 8 is 10. For your information, estimation gives quick value of your calculation, and it also gives you a quick check on what you are calculating. So we look at C part of the problem. For C, I have 2.9 times 39.57. So starting from the first number, 2.9, 2 is the whole number part. So we check the next digit, which is 9. We are rounding it up so that 2 becomes 3. So we have 3 for the first number. Then the second number is 39.57. 39 is the whole number part. So the next digit is 5. So we are rounding it up, and we have our 39 plus 1 to give us 40. So 39 9.57 to the nearest whole number is 40. 3 times 40 gives 120. And that's all for problem 1 under estimation. We then go to problem 2. For problem 2, we are to estimate by rounding off to one significant figure: A 258 plus 28, B 89 times 1.63, and C 7.6 divided by 4.34. It is always advisable, if you are rounding off large number, even small number, to quickly round off to one significant figure to ease your calculation, as we are going to see in this example 2 under estimation. So starting from A part of the problem, we have 258 plus 28 to one significant figure. The first significant figure here is 2, and the next figure is 5. So we are rounding it up by adding 1 to these two to become 300. You remember, after taking this first digit, we resolved the remaining two digits to zeros. So the same thing here. The first significant figure here is also 2. We have 8. We are rounding it up by adding 1 to these 2 to become 3. And our answer will be 30. So we say plus 30. 300 plus 30 gives 330. And that's all for A. Then for B, we have 89 times 1.63. So 89 to one significant figure, we pick this first significant figure, which is 8, add 1 to it, because we have 9 here, it becomes 90, then times 2. Because the first significant figure here is this 1, and the next digit is 6, which is between 5 and 9. We are rounding it up to become 2.00, and we said zeros after the decimal point are negligible, so we have it as times 2. 9 times 2 is 18, therefore 90 times 2 is 180. We then go to problem 2C under estimation. So we have 7.6 divided by 4.34. So 7.6 to one significant figure is 8. Then divide by 4. Divide by 4. I hope you know how we got this 8. 7 plus 1, since this 6 is to be rounded up. And here it is just 4 because this 3 is going to be rounded down. So that 8 divided by 4 gives 2. And that's all for problem 2. We then go to problem 3. For problem 3, a hall has a capacity of 350. Okay, that is to say, the hall can accommodate 350 audience. The cost of a ticket is $125. Estimate the total amount of money that will be raised from the sales of ticket. So if the hall is to be occupied to be full and each ticket is $125, we are to calculate the total amount of money that will be realized. We are going to round off these values and get the total amount of ticket as an estimate. So we have the capacity of the hall to be 350. To one significant figure, we are going to have it at 400. 3 plus 1, because this is 5. 400, that's one significant figure. Cost of ticket is $125. To one significant figure, I'm going to have it as $100. That will give us one significant figure. Remember, this is 1, this is 2. It has to be rounded down, so we have it as 100. So that the estimated total sales of tickets now will be 400 times 100, and that will give us a $40,000. That is the estimated amount of money they are going to realize from the sales of tickets. And that's the end of problem 3 under estimation. This is the highest we can take in this video. I hope you enjoyed it. See you in our next video. Goodbye.